Hey, welcome to Trixaw. In this video, we'll be taking a look at implicit differentiation. Implicit differentiation is used when deriving a variable with respect to a different variable. For example, what would be d dx of L squared? In this example, we're deriving with respect to x. That's why we have d dx in the bottom. But we're differentiating a variable L. Usually, we're used to seeing something like d dx of x squared. And we know this is equal to 2x. But what about d dx of L squared? Well, the answer to this is 2L times dl dx. And the rule for implicit differentiation is first normally deriving your expression, which in this case is L squared, but then multiplying by something else, which is d, the variable that you're deriving, over d, the variable you're deriving with respect to, which is x. And it actually also works with our more common derivatives. For example, this 2x over here is actually 2x times dx over dx because we're deriving a variable x with respect to x. Let's see how we can apply this in a more complex problem. Given x squared plus y squared is equal to xy, find dy dx. So how would we solve this problem? Well, the only way we can start is by differentiating the left and the right side of the equation. So let's go ahead and do that. The derivative of x squared is 2x, but now it gets tricky. Because we have a variable y and we're differentiating with respect to x, we have to use implicit differentiation. So what's the derivative of y squared? Well, it's 2y, but we have to multiply dy over dx. So now let's move on to the right side of the equation. We have x times y, and so in order to differentiate that, we have to use the product rule. So what's x times the derivative of y? That's going to be x times dy dx plus the derivative of x times y, which is just y. So now let's take a look at the problem. We're trying to find dy dx, and we see that expression 2 times inside our equation. So let's try to isolate those terms. We can write 2y times dy over dx minus x times dy over dx is equal to y minus 2x. So now let's factor out dy dx from the left side of the equation. Doing that, we get dy dx times 2y minus x is equal to y minus 2x, which actually gives us a final answer of the derivative of this equation, dy dx, is equal to y minus 2x over 2y minus x. And that's the beauty of implicit differentiation. We're able to find the derivative of more complex functions. Thank you for watching this video. If you have any questions or any other calculus content you'd like me to cover, please just leave a comment down below. Thank you for watching. Don't forget to subscribe.